November 1941, North Atlantic Ocean, 2:47 in the morning. Lieutenant Eric Brown is underwater, in the dark, in December, and his aircraft is sinking around him. The cockpit is filling fast. The harness is jammed. The canopy latch, which worked perfectly in every training exercise, will not move. Outside the glass there is nothing. No light, no surface, no direction, just black water and the sound of metal groaning as the airframe compresses under the pressure. He has approximately 12 seconds before the decision is made for him. He is 28 years old. He has flown 111 different aircraft types. He is about to become a footnote. He does not become a footnote. He gets out. To this day, no detailed account exists of exactly how. Brown himself, when asked in interviews 70 years later, would say only that his hands did something his brain had not consciously instructed them to do. He surfaces in the North Atlantic in December. The water temperature is 4 degrees Celsius. He is conscious. He is pulled from the water by a rescue crew. He has a gash across his left forearm that will leave a scar he carries for the rest of his life. He is back in a cockpit within 6 days. This is the first thing you need to understand about Eric Brown before you understand anything else about him. Not the record, not the German, not Goering. This. The man drowned, climbed out, and went back up. Not because he was ordered to, because the work was not finished. That decision, made quietly in a Royal Navy sickbay, while a doctor stitched his forearm, is the decision that everything else in his life rests on. Now go back 13 years. Because nothing about that moment in the North Atlantic is an accident. Scotland, 1928. An airfield outside Edinburgh. The grass is wet. The morning is gray, the way Scottish mornings are permanently gray, as if the sky signed a contract with the ground and neither party is happy about it. A boy stands at the fence watching a de Havilland biplane roll across the field and lift into the cloud. He is 15 years old. His name is Eric Melrose Brown. He watches the aircraft disappear and feels something he will spend the rest of his life trying to describe accurately and never quite manage. Not excitement, not wonder. Something colder than both of those. The feeling of recognizing something that belongs to you. His father, Robert Brown, flew in the First World War, Royal Flying Corps. He survived, which puts him in a minority of about 40% of men who flew in that war. Robert Brown does not tell his son romantic stories about aviation. He tells him the truth. He tells him about navigating by church steeples because instruments failed, about watching a man he had eaten breakfast with that morning spin into the ground because a control wire frayed at the wrong moment, about the way your hands shake for an hour after a near miss and the way you learn to eat breakfast anyway, because if you wait for the shaking to stop, you will never eat again. Eric listens to every word, and then he asks his father to teach him German. Robert Brown spoke German from his time in Europe before the war. He believed it was the language of engineering, of precision manufacturing, of serious technical thought. He taught his son. Eric Brown learned German the way children absorb languages when they are young enough, not as translation, but as a second way of thinking. He did not know at 15, standing at that fence in Edinburgh, that this combination, the instinct for flight and the fluency in German, would make him the most valuable and most used aviation asset in British military history. He did not know it would also make him the most tested man alive. He just wanted to fly. By 1937, he is 24 years old and studying modern languages at the University of Edinburgh. He speaks German without accent. He has been flying since his father arranged his first lesson at 15, and he is already past the point where instructors have things to teach him. He has a quality that people who flew alongside him described the same way across decades of interviews. Not brave, not reckless, precise. A mechanical calm that is not the absence of fear, but the ability to keep thinking while fear is happening. That summer he travels to Germany on a student exchange program. He attends the International Air Meeting in Zurich. He watches the Luftwaffe conduct a flying demonstration that is not really a demonstration. It is a message. The Messerschmitt Bf 109 performs maneuvers that the British observers watch with diplomatic expressions and private terror. Brown watches with something different. He is cataloging. Speed, turn radius, climb rate, the angle at which the wings flex under load. He is storing information the way a pilot stores information, not as data, but as felt knowledge. After the display, he meets Ernst Udet, First World War ace, 62 aerial victories. Charming, openly proud of what Germany has built, the kind of man who mistakes confidence for security. They talk for 2 hours. Udet invites Brown to fly a German trainer. Brown accepts. He climbs into a German aircraft on German soil in 1937 and flies it well enough that Udet applauds when he lands. "You fly like someone who has been doing this since before he could walk," Udet tells him, in German, laughing. "Almost," Brown says. Also in German. Udet stops laughing, looks at him differently. "You should come back," he says. "We could use someone like you." Brown smiles and says nothing. 2 years later, Germany invades Poland, and the compliment becomes one of the stranger things anyone has ever said to him. Britain declares war in September 1939. Brown enlists the same week. He has 340 hours of flying time, perfect German, and personal contacts inside the Luftwaffe. He is 26 years old, and he wants to fly combat. He wants to do what his generation believes it is supposed to do. Get into the fight. Contribute directly. Come back with a kill count, or not come back at all. But either way, make the choice yourself. The Royal Navy looks at his file and makes a different choice for him. He is assigned to an aircraft evaluation unit at Farnborough. His job? Fly captured German aircraft and report on their capabilities. That is it. That is his war. His friends are flying Hurricanes over France. They are meeting Messerschmitts over the Channel. They are part of the Battle of Britain, a phrase that will mean something forever. Eric Brown is in a hangar in Hampshire, climbing into a captured Heinkel. He 111 bomber, with a German technical manual on his knee, learning how the enemy built their aircraft from the inside out. He asks once, formally, to be reassigned to a fighter squadron. The request is reviewed and denied in 11 days. The response, which he kept, reads, "Officer's current assignment represents optimal utilization of specialist capabilities. Transfer request declined." 11 words to explain why he would spend the most important war of the century as the man who flew the enemy's planes so that other men could shoot them down better. He understood the logic. He hated it anyway. Then he got to work. What Brown did at Farnborough between 1939 and 1945 has no real parallel in aviation history. He flew German aircraft that arrived from combat theaters in various states of damage and repair. Some came from crash sites in France, partially rebuilt. Some were flown out by defecting pilots. Some arrived in crates, disassembled, and had to be reconstructed before he could fly them. Each one was, in a specific technical sense, unknown. There was no manual written for British pilots flying captured Luftwaffe aircraft. There was no precedent. There was just Brown, the aircraft, and whatever German documentation had come with it. The Focke-Wulf 190 arrives in 1942. This aircraft has been destroying British fighters over the Channel in a way that is causing genuine crisis at command level. The Spitfire. Mark V, which was supposed to be the answer to the Messerschmitt 109, is being outclassed. Pilots are dying at a rate that the official reports describe in careful bureaucratic language that does not capture what is actually happening, which is that young men are being killed by a machine that their own machines cannot match. Brown flies the Focke-Wulf 190 for 11 days. He writes a report. The report is classified immediately. The conclusions go directly to the Supermarine design team working on the Spitfire Mark IX. Within months, the Mark IX is in production. It is faster, more powerful, and capable of fighting the Focke-Wulf on equal terms. The tide over the Channel begins to shift. Brown's name is not in any of the public records about that shift. The report exists in an archive. His name is on it. But the story that gets told is about the engineers who designed the Mark IX and the pilots who flew it. Not about the man who climbed into the enemy aircraft and came back with the information that made the redesign possible. By 1943, he has flown 150 aircraft types. He has been in 3 serious accidents. He has been pulled out of the North Atlantic, walked away from a wheels-up landing that destroyed the aircraft and left him with 2 cracked ribs, and survived an engine failure on final approach that he managed to turn into a controlled crash landing by a margin that the accident report described as exceptional airmanship, and that Brown himself described as luck. He does not tell his mother about any of it, because she would ask him to stop, and he would have to explain that he cannot stop. The work is not finished. May 1945. Germany surrenders. The Allies move through the collapsed Reich and find, in the rubble of what was the most advanced military aviation program in the world, things that do not make sense. Aircraft that look like they are from a decade that has not arrived yet. Jet engines generating thrust that British engineers had believed was 5 years away. Rocket-powered interceptors. Swept-wing designs that rewrite the assumptions of aerodynamics. And sitting in captured facilities, in varying states of cooperation, the engineers and test pilots who built all of it. The British need to understand what they have found, not just the hardware, the thinking behind the hardware, the decisions that were made, the directions that were abandoned, the capabilities that were never fully developed, and the ones that were. This requires someone who can sit across a table from a German aviation engineer who spent 6 years building weapons designed to kill British pilots, look him in the eye, and have a technical conversation in his own language that extracts real information instead of carefully managed partial truth. They need someone who knows enough about German aircraft to know when a German engineer is lying. There is exactly one person available who can do this. Eric Brown is 32 years old. He has flown 187 aircraft types. He speaks German without accent. He has personally flown more Luftwaffe aircraft than many Luftwaffe pilots. He knows the Focke-Wulf 19. Oh, the way its designers know it, from the inside, from the cockpit, from the specific feeling of the controls at the edge of the aircraft's capability envelope. He packs a bag and flies to Germany. The list of men he is sent to interview includes scientists, engineers, test pilots, and commanders. It includes Kurt Tank, who designed the Focke-Wulf 190. It includes Hannah Reitsch, the most famous female test pilot in history, who flew aircraft that her own colleagues refused to approach. It includes men who designed the V-1 and V-2 programs. And it includes Hermann Goering, commander of the Luftwaffe, second most powerful man in the Third Reich, now a prisoner at Nuremberg, awaiting trial for crimes that will end in his execution. Brown walks into that room with a notepad and a question list, and the calm that has been his defining characteristic since a Scottish airfield in 1928. Goering looks at him. Brown looks at Goering. They begin to talk. What Goering says in that room, and what Brown concludes from it, will not be declassified for decades. But Brown himself, when asked about it in the last years of his life, said something that stopped every interviewer cold. "He was the most intelligent man I met during the entire war," Brown said, "and the most completely wrong about everything that mattered. That combination is the most dangerous thing a human being can be." Nuremberg, November 1945. Hermann Goering sits across a wooden table from Eric Brown and does something nobody expected. He laughs. Not the broken laugh of a defeated man performing dignity. A genuine laugh, because Brown has just told him, in perfect German, that he personally flew the Focke-Wulf 190 for 11 days in 1942 and found the rudder response at high speed to be, in his exact words, unnecessarily aggressive for a production aircraft. Goering stares at him for a moment. Then he laughs and says, "Kurt Tank argued with me about that rudder for 6 months. I told him pilots would adapt. He told me pilots would die. You are telling me Tank was right." Brown says nothing. He writes it down. Goering leans forward. "How many German aircraft have you flown?" Brown tells him the number. Goering is quiet for a long moment. Then he says quietly, without any performance in it, "More than most of my pilots." This is the room where the second chapter of Eric Brown's life begins. Not a cockpit. A prison interview room in Nuremberg with a man who built the most advanced air force in the world and then watched it destroyed. Brown is 32 years old. He has survived the North Atlantic and 3 crashes and 6 years of climbing into aircraft that were designed by people who wanted to kill him. He has done all of that in relative anonymity, classified reports, and denial of transfer requests, and a career that exists entirely in files that the public will not read for decades. Now he is sitting across from history, and he is completely calm. To understand what Brown was doing in Germany in 1945, you need to understand what the Allies found when they got there. The assumption, going into the final months of the war, was that German aviation technology was broadly comparable to Allied technology, better in some areas, behind in others. The Me-262 jet fighter was known, the V weapons were known, but the full scope of what Germany had been developing, the programs that never reached production, the experimental aircraft sitting in camouflaged hangars in Bavaria and Thuringia, the design documents and wind tunnel data and test flight records, none of that was known. What the Allied teams found was not comparable technology. It was a different generation of technology. The Heinkel Hu-162 jet fighter which had actually entered limited service, was designed, built, and flown to operational standard in 90 days. 90 days from blank paper to a jet aircraft doing 500 miles per hour. The Americans and British were genuinely shaken when they understood that timeline. Not because the aircraft was perfect. It was not. It had serious stability problems that killed several test pilots during development. But the speed of development, the institutional capacity to move that fast, revealed something about German engineering culture that the Allies had not fully appreciated while they were fighting it. Then there was the Horton-Ho 229, a flying wing. Twin jet engines, designed with a specific geometry that, when American engineers ran the numbers decades later, turned out to have significant radar-absorbing characteristics. In 1945, the Americans would not fly a production stealth aircraft until 1983. The Germans were building the conceptual predecessor in a workshop in 1944. Brown walked through these facilities and understood, with the specific clarity of someone who had flown aircraft across the entire performance spectrum, from 1930s biplanes to jet fighters, exactly what he was looking at. He was looking at the future that had been interrupted, and his job was to understand it well enough to make sure the right people in Britain understood it too. He interviewed Kurt Tank, the designer of the Focke-Wulf 190, for 3 days. Tank was cooperative, precise, and almost entirely without regret about the professional work he had done. He spoke about aircraft design the way a craftsman speaks about furniture, with technical pride that existed separately from the uses the furniture had been put to. Brown found this deeply uncomfortable and professionally invaluable. Tank's explanations of the design decisions behind the 190 filled gaps in Brown's understanding that 6 years of flying the aircraft had not resolved. There are things you cannot feel from the cockpit. Tank explained them, sitting at a table in a requisitioned German office building, with a cup of tea that a British sergeant had made badly. Hannah Reich was different. Reich was the most decorated female pilot in history. She had flown the V-1 flying bomb in a manned test configuration, sitting in a cockpit, bolted onto a pulse jet weapon that was designed to be unrecoverable, to assess its handling before it was deployed as an unmanned weapon. She had flown the Me-163 rocket-powered interceptor, an aircraft that its own designers described as more dangerous to the pilot than to the enemy. She had landed a helicopter inside the Reichstag during a demonstration in 1938. She had, by any measurable standard, done things in aircraft that should have killed her multiple times. Brown met her in a detention facility outside Munich. She was small, composed, and absolutely certain that everything she had done was correct. Not defensively certain. Serenely certain, the way people are certain about things they have never once allowed themselves to question. He asked her about the V-1 manned tests. She described the experience in technical detail. The vibration from the pulse jet that made instrument reading almost impossible. The control response that was acceptable at cruise speed and dangerous at anything above it. The specific sound the engine made when it was about to flame out, a sound she said she could identify within half a second and respond to before the instruments confirmed it. She described all of this with the calm precision of a test pilot debriefing, because that is exactly what she was. Brown wrote it all down. He did not tell her that her technical precision was remarkable and her moral framework was catastrophic. That was not his job. His job was the information. But he told an interviewer about it in 2012 when he was 99 years old. And he said this: "She was one of the finest pilots I ever met. And she had flown for a regime that murdered millions of people with genuine enthusiasm. I have spent 70 years not knowing what to do with that combination." The interviews ended in early 1946. Brown returned to Britain with notebooks, reports, and a level of knowledge about German aviation that no other living person possessed. The reports were classified. The notebooks went into archives. Brown went back to Farnborough. And they gave him more aircraft to fly. This is the part of the story where the number starts to become difficult to process. Because by 1946, the jet age has arrived properly, and it has arrived with a specific problem that is going to kill a significant number of pilots before anyone fully understands it. The problem is called compressibility. As aircraft approach the speed of sound, the airflow around the wings behaves in ways that 1940s aerodynamics did not predict, and that 1940s pilots were not trained for. Control surfaces stop responding normally. In some configurations they reverse. An aircraft that you push forward goes up. An aircraft that you pull back goes down. The controls you have relied on your entire career are lying to you, and they are lying to you at 500 miles per hour. And you have approximately 4 seconds to figure that out before you are no longer a problem that anyone needs to solve. Pilots were dying in ways that accident reports struggled to explain because the physics involved were not yet in any textbook. Brown was given these aircraft, not after the problem was understood. While it was being understood, his job was to fly into the regime where the aircraft started doing the wrong things and come back and describe exactly what happened. This required, in practical terms, deliberately inducing the conditions that were killing other pilots and then surviving them. He did this not once or twice as a demonstration. He did it systematically, flight after flight, pushing further into the danger zone on each pass, mapping the boundary between controllable and uncontrollable the way a cartographer maps a coastline, one careful measurement at a time. He had 2 serious incidents during this period that are documented. One resulted in a forced ejection at low altitude that left him with compressed vertebrae in his lower spine, a pain he managed for the rest of his life without ever describing it as a reason to stop flying. The other resulted in a landing in a field in Wiltshire, in an aircraft that had partially lost its hydraulic system, which Brown managed with the specific combination of technical knowledge and manual skill that had become the signature of everything he did. The accident report on the Wiltshire landing noted in the dry language of official aviation documentation that the successful outcome was attributable to the pilot's superior technical knowledge of the aircraft's systems and exceptional manual flying skill under emergency conditions. Brown read the report and crossed out the word exceptional and wrote ordinary in the margin. He was not being modest. He was being precise. By 1947, this was ordinary for him. He had done it enough times that it was simply what landing a broken aircraft felt like. Here is the number that stops people. By 1949, Eric Brown has flown 487 different aircraft types, not variants, not versions with different engines or modified wings. Different types. 487 machines that each required a different set of instincts, a different set of control responses learned and stored and held separately from every other set, a different set of potential failure modes understood and prepared for. The closest comparison in any other field would be a surgeon who has performed 487 different surgical procedures, each with its own anatomy, its own instruments, its own ways of going wrong. Except the surgeon, if something goes wrong, loses a patient. Brown, if something went wrong, lost himself. The Guinness Book of Records will not officially recognize this number until the 1990s, 4 decades after Brown establishes it. Because for most of that time, the full scope of what he flew is classified. The aircraft he flew for intelligence purposes, the captured German and Japanese machines, the experimental programs that were officially denied, do not appear in public records. Brown knows what he has done. A small number of people inside British military aviation know what he has done. Nobody else does. He does not talk about it. Not because he was ordered not to, though for some of it he was, but because Brown had a specific relationship with his own accomplishments that the people who knew him found both admirable and slightly maddening. He did not think of the number as an achievement. He thought of it as a log, a record of work completed. The aircraft he had flown were not trophies. They were problems he had been given and solved. His logbook, which survives and has been examined by aviation historians, is one of the most remarkable documents in the history of flight. It reads like a catalog of the entire development of aviation from the 1930s through the 1960s, written in Brown's precise handwriting, with short technical notes after each entry. The entries for captured German aircraft are particularly striking. Each one begins with aircraft type, date, and location. Each one ends with a brief technical assessment. Between those 2 points is a record of a man systematically learning how the enemy thought about flight, one cockpit at a time. But 1950 brings something new. Something that Brown's logbook and his classified reports and his interviews with enemy engineers have not fully prepared him for. Because the jet age has arrived on aircraft carriers, and aircraft carriers, it turns out, are trying to kill every jet pilot who lands on them. The statistics are precise, and they are brutal. In 1950, the United States Navy records 776 Class A aviation mishaps. The definition of Class A is death or total aircraft loss. 776 times in 1 year. More than 2 per day. A significant portion of these accidents happen in the last 30 seconds of a carrier landing approach when a jet pilot is committed to the deck, unable to abort easily, flying at speeds that the carrier's arresting gear was never designed to handle, heading toward a crash barrier that stops the aircraft approximately 60% of the time and turns it into a fireball the other 40%. Brown knows these numbers. He has been landing on carriers since 1941. He has felt the specific terror of a straight-deck approach in a jet, the way the aircraft wants to float, the way the engine response lags when you need it most, the way the barricade sits at the end of the deck like a promise that the mathematics will eventually collect on. And then in 1951, a bureaucrat named Dennis Campbell draws a line on a piece of paper. Brown reads Campbell's proposal and understands it in about 45 seconds. An angled flight deck, 10 degrees to port. If a pilot misses the wires, instead of hitting the barricade, he flies off the angled deck into open air and goes around. Simple. Obvious in retrospect. Revolutionary in practice. Brown also understands immediately that this idea is going to be rejected by everyone whose approval it needs. Not because it is wrong, because it is right in a way that makes the previous design look like a preventable mistake, and institutions do not enjoy being shown their preventable mistakes by a non-engineer who thought of it on a train. He volunteers to be the test pilot. He makes 63 landings on the painted angled deck outline on HMS Triumph. 63 approaches, where the safety net is a line of white paint on a real, straight deck, where missing the painted wires means hitting the real barricade, where the entire test is contingent on Brown flying precisely enough to make the simulation valid. He does this not to prove that the concept works, though it does work. He does it because the concept needs a name attached to it that the Americans will take seriously. And Brown, by 1951, has the only name in naval aviation that carries that kind of weight on both sides of the Atlantic. When the Royal Navy sends someone to brief the United States Navy on the angled deck, they send Eric Brown. He walks into a room of 40 American test pilots at Patuxent River, Maryland. And he does not start with the concept. He starts with a question. "Gentlemen," he says, "how many of you have hit the barricade?" He watches the hands go up. "How many of you know someone who died hitting the barricade?" Every hand in the room goes up. Brown opens his briefcase. "I have made 63 landings on an angled deck," he says. "I am standing here. So, I am asking you to hear me out." The room does not go quiet because they trust him. The room goes quiet because every man in it has spent years filing away the fear of that barricade in a place where it cannot interfere with the job. And Brown has just walked in and opened the file. What happens next in that room will change carrier aviation forever. But it will take longer than it should, and it will cost more than it needs to because the people with the power to approve it are not the people who are dying. They never are. Patuxent River, Maryland. September 14th, 1951. The room has 40 American test pilots in it, and the temperature is wrong. Not the air temperature. The temperature of the room, the specific atmospheric pressure of 40 men who have decided before you open your mouth that you are wasting their time. Brown feels it the moment he walks in. He has felt it before. In Nuremberg. In Munich. In every room where he walked in. As the person with information that the people in the room did not want to receive, he sets his briefcase on the table. He does not open it yet. "Gentlemen," he says, "how many of you have hit the barricade?" Silence. Then 7 hands. Then 12. Then 15. "How many of you know someone who died hitting the barricade?" Every hand in the room goes up. Brown lets that hang in the air for exactly 3 seconds, long enough to be felt, short enough not to be theatrical. "I have made 63 landings on an angled deck," he says. "I am standing here instead of being pulled off a deck somewhere, so I am asking you to hear me out." He opens the briefcase. He pins Campbell's diagram to the wall. A flight deck angled 8 degrees to port. Simple enough that a child could draw it. Revolutionary enough that the room immediately explodes. "You want us to land sideways. The LSO cannot see the approach angle from the island. You have moved the entire landing zone toward the superstructure." Brown waits. He has heard every one of these objections before. He heard them at the Ministry of Supply in London. He heard them at Farnborough. He heard them from men with engineering degrees and admirals with 30 years of carrier operations behind them. He waited then, too. Every objection you just made, he says, we had. Every single one. Then we tested it. Commander Harold Buell stands up, commanding officer of VF-84. The kind of American naval aviator who was landing on carriers before Brown had his first cup of coffee in a Fleet Air Arm briefing room. He has the posture of a man who has earned the right to be skeptical and intends to use it. Commander Brown, I have been landing on carriers since 1943. What you are describing throws away 8 years of proven doctrine for a British theory. You are asking us to trust a painted line. Brown looks at him. I am asking you to stop dying for a design flaw. The room goes quiet in a different way than before. Not the hostile quiet of men who have decided not to listen. The specific quiet of men who have just heard something they already knew, said out loud by someone they cannot dismiss. Buell sits down slowly. What Brown understood in that room, and what made his presentation different from every bureaucratic attempt to move the angled deck concept forward, was this. He was not talking to administrators. He was talking to pilots. And pilots do not respond to statistics the way administrators respond to statistics. Administrators see numbers. Pilots see the specific faces behind the numbers. They see the man who hit the barricade in March. They see the aircraft that went into the parked Corsairs. They see the fireball and the accident report and the letter that someone had to write to a family. Brown had 63 landings on the system. That number meant something in that room that it could not mean anywhere else. Not because 63 is a large number, though for an untested concept on a painted deck it is significant, but because Brown was standing there alive and intact and describing something from direct experience rather than theoretical analysis. In a room full of men whose entire professional framework is built around the difference between knowing something and having done something, that distinction is everything. Rear Admiral Apollo Susek, the senior U.S. Navy aviator who had observed the Triumph trials in Britain, steps forward and confirms what Brown has said. He has already recommended to the Chief of Naval Operations that parallel trials be conducted on USS Midway. The room understands that the decision has largely been made. What Brown has done is not persuade the administrators. He has given the pilots permission to believe in it. Rear Admiral Alfred Pride, Chief of the Bureau of Aeronautics, gives his approval in the specific way that men who have been overruled give approval. Precisely, correctly, and with a warning attached. If this British concept causes a single additional casualty, he says, the program ends. Brown nods. He packs up the briefcase. He flies back to Britain. He does not tell anyone what it cost him to stand in that room. But his deputy at Farnborough, a man named Lieutenant Commander Jeffrey Cooper, later described Brown returning from Patuxent River and sitting in his office for 40 minutes without speaking. Cooper brought him tea. Brown drank it. Then he said, "They are going to test it. If it works the way it worked on Triumph, some of those men in that room are going to live who otherwise would not have." He paused. "If it does not work the way it worked on Triumph, that is on me." Cooper said he had never heard Brown speak about personal responsibility in those terms before or after. Brown did not explain further. He went back to work. The Midway trials work. They work so completely, so immediately, and with such clear data that within 90 days the United States Navy authorizes the conversion of USS Antietam into the first true angled deck carrier in the world. Not a painted outline, a structural modification. 8 degrees of angled flight deck welded into the hull, extending the landing area to port, eliminating the barricade from the equation entirely. January 12, 1953. Off the coast of Guantanamo Bay. Lieutenant Commander Harold Buell, the man who stood up in the briefing room at Patuxent River and challenged Brown directly, brings his F-9 F-5 Panther into the landing pattern behind USS Antietam. This is his first approach to an angled deck that is not painted. It is real. He drops his landing gear, calls the ball, and flies a perfect approach until a wind gust lifts him 6 feet high at the last moment. He floats. He misses all 4 wires. On a straight deck, this is the moment where the barricade rises and the calculation becomes catastrophic. On Antietam, there is no barricade. There is open deck and clear air and a second chance that the straight deck never offered. Buell shoves his throttle to full power. The engine spools up. The Panther lifts. He is flying again. 23 seconds later, he is back in the pattern. Second approach. 3 wire. Perfect landing. Buell climbs out of the cockpit and sits on the deck for a moment before the deck crew reaches him. Not injured. Not shaken. Something else. The specific feeling of a weight being removed that you had carried so long you had stopped noticing. It was there. He will write about this moment in his autobiography with a clarity that suggests he thought about it for years before he found the right words. For the first time in my career, he writes, I was not afraid of dying during the approach. I did not know I had been afraid until the fear was gone. Brown receives the data from the Antietam trials at Farnborough. 1,327 landings, 8 bolters, 0 barrier crashes, 0 destroyed aircraft, 0 injuries. He reads the report twice. Then he walks to the window of his office and stands there for a moment that Cooper, who was present, described as the only time he ever saw Brown look like something had reached him. He just stood there, Cooper said, looking at nothing. Then he said, very quietly, "Good." That was all. Just good. And then he went back to his desk. The numbers that follow over the next 4 years are the validation of everything. Before the angled deck, U.S. Navy carrier Aviation averages 647 Class A mishaps per year. After implementation, that number drops to 321. Landing accidents fall from 52% of all losses to 19%. Barrier-related fatalities drop by 80%. 80%. That is not an engineering improvement. That is not a design refinement. That is hundreds of men per year who go home instead of being written into an accident report. It is letters that do not get sent to families. It is children who grow up with fathers. It is the specific, tangible, countable result of one bureaucrat's sketch on a train and one test pilot's 63 landings on a painted line and one presentation in a room in Maryland, where Brown asked 40 pilots to raise their hands. By 1955, the British have implemented the angled deck on HMS Ark Royal, the first carrier in history designed from the keel up with the angled deck as a structural feature rather than a modification. The French convert Clemenceau. The Australians modify Melbourne. By 1957, every major carrier in the Western world either has an angled deck or is being retrofitted. Brown is at Farnborough for all of it. Not at the commissioning ceremonies, not at the press events. At Farnborough, flying. The number of aircraft types climbs past 500. The work continues. He is 42 years old. He has ejected twice, crashed 4 times, survived the North Atlantic, flown the aircraft of 3 separate nations at war, sat across from Hermann Goering and Hannah Reich and Kurt Tank, made 63 landings on a painted deck to prove a concept that saved thousands of lives, and briefed the United States Navy in a room where the temperature was wrong and changed it. His name is in classified files. His name is on reports that shaped the development of British and American aviation for a generation. His name is not in newspapers. His name is not in history books. His name is not attached to the angled deck in any public record, because his role was test pilot and presenter, and the credit goes to Campbell and the engineers at Farnborough, which is correct and incomplete in equal measure. He does not complain about this. He is asked about it directly in an interview in 1970, and he says something that the interviewer writes down and then does not use because it does not fit the shape of the story the interviewer is trying to tell. Brown says, "I did not do any of it for the record. I did it because the aircraft needed to be flown and I was the one available. The record is what happened. It is not why it happened." The interviewer moves on to the next question. Brown goes back to Farnborough. There is one more aircraft he has not flown yet. There is always one more aircraft. Edinburgh, 2014. A journalist named James Holland sits across from a man who is 101 years old and asks him a question that nobody has asked before. Not because it is a difficult question, because for 60 years, nobody thought to ask it. Do you ever think about the ones you could not save? Eric Brown looks at him for a long moment. Outside the window, Edinburgh is doing what Edinburgh does in November: gray sky, wet stone, the kind of cold that has opinions about you. Brown is sitting in a chair by the window. He is small now, the way very old men become small, as if the body is slowly returning itself. But his eyes are the same eyes that looked at Hermann Goering across a table in Nuremberg and did not flinch. He says, "Every day." Then he says, "That is why I kept going up." This is the answer that explains everything. Not the record, not the German, not the 63 landings on a painted deck. This, the fact that for 70 years, Eric Brown went to work every morning carrying the names of men he could not reach in time, and turned that weight into fuel instead of letting it become paralysis. That is not a skill you can teach. That is a choice you make so many times it stops feeling like a choice and becomes the shape of who you are. By 1960, Brown has done something that has no precedent and will have no successor. He has flown 487 different aircraft types. The number is now complete. Not because he stopped flying, because the era that made the number possible has ended. The age of mass aircraft development, the period between 1930 and 1960, where dozens of fundamentally different aircraft were designed, built, tested, and either adopted or discarded every year. That age is over. The jet age has consolidated. There are fewer types now, more refined, more expensive, built in smaller numbers and operated for longer periods. The 487 will stand forever. Not because no one tries to match it, because the conditions that made it possible will never exist again. But here is the fact that stops every person who hears it for the first time. The Guinness Book of Records does not officially recognize Brown's record until 1993, 40 years after he establishes it. Not because there is any dispute about the number, because the majority of the aircraft he flew are classified. The captured German machines, the experimental programs, the intelligence-related test flights, the aircraft whose existence the British government officially denied for decades. None of them appear in public records. Brown knows what he has done. A small number of people inside British military aviation know what he has done. The rest of the world does not. He spent 40 years holding a world record that he was not allowed to claim. When the Guinness recognition finally comes in 1993, Brown is 80 years old. A journalist asks him how it feels to finally have the record officially acknowledged. Brown considers the question with the patience of a man who has learned that most questions deserve more thought than people give them. It feels the same as it felt before, he says. The aircraft were real, whether the record was official or not. The men who died were real, whether anyone wrote their names down or not. A number in a book does not change what happened. The journalist writes this down. It runs as a pull quote. Nobody follows up on what he means by the men who died. Brown retires from the Royal Navy in 1970 with the rank of captain. His service record, the parts of it that are not classified, lists decorations, commendations, and a career summary that occupies 4 pages of official documentation and captures approximately 15% of what he actually did. He takes a position as a test pilot consultant. He writes. He lectures at aviation institutions. He becomes slowly and without seeking it, the living memory of an era that is passing out of living memory. The men who flew in the Second World War are aging. The test pilots of the early jet age are dying. The institutional knowledge of what it felt like to fly those aircraft, not the technical specifications, but the felt experience. The specific way a Focke-Wulf 190 wanted to swap ends if you pushed it too hard, the exact sound a Merlin engine made when it was about to fail, the temperature of the North Atlantic in December when it is trying to kill you. All of that knowledge exists in fewer and fewer living human beings. Brown understands this with the same clarity he brought to cockpits for 40 years. He starts giving interviews, long ones, detailed ones. He corrects the historical record on specific points with the precision of a man who was present and remembers exactly what happened and finds inaccuracy offensive in the specific way that precise people find inaccuracy offensive. He does not soften things. He does not perform modesty. He says what happened, and he says what it meant, and he says what it cost, and he leaves it to other people to decide what to do with that information. In 2003, a United States Marine Corps pilot named Lieutenant Colonel Arthur Black tracks down Brown's family and sends a letter. It reads, "I never met your father, but I made 147 carrier landings during my career. I boltered 42 times, missed all the wires, and had to go around. On a straight deck, 42 bolters means 42 potential barrier crashes. 42 times I might have died or killed the men working forward. Instead, I just climbed away and tried again. Your father gave me 42 second chances. He gave me a career. He gave me a life. My children exist because Eric Brown stood in a room in Maryland and refused to let pilots keep dying for a design flaw. Thank you does not cover it. But thank you. Brown's son frames the letter because his father keeps no awards, no citations, no commendations on display in his home. Not from false modesty. Because Brown does not organize his life around what he has been given. He organizes it around what the work required. But his son knows. He frames it anyway. Here is what the record actually means, stated plainly, because it deserves to be stated plainly. Between 1953 and 2023, the United States Navy alone has conducted approximately 1.2 million carrier landings. The bolter rate across that period averages roughly 8%. That is 96,000 missed wire approaches. On straight-deck carriers, a significant percentage of those would have resulted in barrier crashes. Conservative estimates from naval aviation historians suggest the angled deck has prevented somewhere between 15,000 and 30,000 deaths in the U.S. Navy alone across 7 decades. Add the Royal Navy, the French Navy, the Indian Navy, the Australian Navy, and every other carrier operating force in the world, and the number is larger than any single weapons system has saved in the same period. Eric Brown made 63 landings on a painted line to make that number possible. He was never on the front page. He was never the subject of a film. His name does not appear in most histories of carrier aviation. The angled deck is attributed to Dennis Campbell correctly, because Campbell drew the sketch and fought the bureaucracy and deserves every credit he receives. But Brown is the man who made it real. He is the man who climbed into the cockpit and proved it worked when proving it meant that if it did not work, he was the one who would not come home. April 2016, Edinburgh. Eric Brown gives what will be his last extended interview. He is 102 years old. He is still precise, still direct, still capable of correcting a factual error with the slightly impatient tone of a man who has been correcting factual errors for 80 years and has not yet made peace with the fact that people keep making them. The interviewer asks him what he is most proud of. Brown thinks about this for longer than he has thought about any other question in the interview. The landings on Triumph, he says, finally. The 63. Not because of what came after, because of what they required. I knew, going into each approach, that the painted line was not a real deck edge. I knew that missing the wires meant the real barricade was waiting. I knew that if I flew those approaches with anything less than full precision, I would invalidate the entire test. Every single approach had to be exactly right, or the data was worthless. He pauses. That is what I am proud of. Not that I survived. That I flew precisely enough 63 times in a row, that the data was clean, that nobody could look at the results and say the test was compromised. He pauses again. The rest of it, the number, the record, the interviews with the Germans, that was just work. You do the work in front of you. You do it as well as you can. You go back up the next day. The interviewer asks if he ever wanted to stop. Brown looks out the window at Edinburgh. He takes his time. There was a morning in 1942, he says, after the Atlantic. I was sitting in the sick bay, and my arm hurt, and I was cold, in a way that took 3 days to stop being cold, and I thought very clearly that I could simply not go back up, that nobody could make me, that I had done enough and survived enough, and the reasonable thing, the sane thing, was to find a different way to contribute. He stops. What happened? The interviewer asks. I thought about Michael Lithgow, Brown says. He was a pilot I had trained, 23 years old. He died in a barrier crash on Implacable. Perfect approach, perfect speed, 6 feet afloat, and he was gone. His wife was pregnant. Brown is quiet for a moment. I thought about him, and I thought about the fact that the aircraft that killed him was still up there, still wrong, still going to kill the next pilot who floated 6 feet. And I thought that if I did not go back up and fly the thing that was going to tell someone how to fix it, then Michael Lithgow died for nothing, and the next one would too. He looks back at the interviewer. So I went back up. He died 3 months later, on February 21st, 2016. He was 102 years old. He had flown 487 aircraft types. He had survived 4 crashes, 2 ejections, and the North Atlantic in December. He had interviewed the architects of the Third Reich's Air Force and reported what they told him. He had made 63 landings on a painted line and changed the survival rate of carrier aviation for every generation that followed. His obituary in the Times was 6 paragraphs. The 6th paragraph noted that he was survived by his son and that he had expressed a wish for a small private funeral. No ceremony, no speeches, just the work, completed. And somewhere, at this exact moment, a pilot is on final approach to a carrier somewhere in the world. The deck is angled 8 degrees to port. The pilot does not know why it is angled. They never taught him. It is simply how carriers work. It has always been how carriers work. He catches the 3-wire. He never knows whose 63 landings gave him that second chance.